Hey everyone, thanks for joining us today. Ever struggle with sudden jumps in cloud traffic or slow network performance? It's tough to keep up with your apps, especially to keep them always speedy and always on, especially when network traffic changes so unexpectedly. I am Ananta Ramachandran, and I'm here with my colleagues from DigitalOcean, Uday Ravindran and Vasily Prokopov. We are excited to talk about smarter traffic management using load balancers. We want this session to be super interactive, so please feel free to drop your questions in the chat window. Today, we will dive deeper into how to use load balancers to manage your network traffic. In addition to that educational content, as a token of our appreciation for your participation today, we are excited to present with you some incredible offers. If you haven't registered already for this webinar and are joining us live using some social channels, we request you, please be sure to scan the QR code that you see on the screen and or use the URL to register now for this session to receive a follow-up email containing the links to the videos and offers that you can use to take next steps. Again, in this session, we will cover top traffic management challenges, how to pick the best load balancer for your needs, and how to make the most out of it. This session and our offers are perfect for anyone who deals with network traffic management. I'll kick off things with our mission statement. At DigitalOcean, we are all about making cloud and AI simple so you can spend more time building the software that changes the world. DigitalOcean powers customers worldwide. We have 17 data centers across 9 regions that support over 638,000 customers in 190 countries. Our proven track record of uptime and performance helps businesses scale with confidence. Most hyperscalers offer clouds and solutions that may not be a good fit for digitally native enterprises. Right? These hyperscaler solutions could be overly complex, cost prohibitive, and could lock you in contracts and offer only limited support. At DigitalOcean, we are purpose-built to solve the unmet needs of many such digital native enterprises like yours. For example, right, you may be operating lean teams. You do not have an army of DevOps or Cloud Ops or FinOps specialists. You need a cloud that is simple to manage across its entire life cycle, right? Not one that demands a ton of overhead just to keep the lights on. That's where we come in. DigitalOcean delivers a simple, full-featured cloud that's easy to scale as your needs grow, and all backed by enterprise-grade SLAs to support your mission-critical products and services. We are also a trusted partner, not a walled garden. You'll get a transparent pricing, predictable cost, 24/7 support when you need it, and the freedom of an open ecosystem that grows together with you. In short, DigitalOcean offers a simple, scalable, and approachable solution, and that's the DigitalOcean difference that empowers many customers worldwide. We offer comprehensive cloud services for various business needs. Right? At its core, DigitalOcean offers infrastructure as a service, providing things like virtual machines, storage, both volume storage as well as object storage, and networking solutions to power your cloud infrastructure. Building on that, we offer platform as a service, solutions like managed databases, app platform, which enables users to easily build and deploy managed Kubernetes applications. We also provide cloud web hosting solution for your web needs. Lastly, we offer SaaS offerings too, especially AI platform and AI offerings such as AI agents and a wide range of third-party applications available through our marketplace, allowing customers like you to extend and enhance your cloud capabilities. I want to zone in a bit on networking solutions, which is what this session is primarily about. We offer a range of networking solutions to help customers seamlessly connect and secure their cloud resources. For example, we offer VPCs, right? You can easily create private, isolated networks to enhance security and control over your cloud resources. We also offer load balancers to help you scale applications effortlessly while improving availability, security, and performance with just few clicks. Right? We offer cloud firewalls that can help you protect against cyber threats, control service visibility on your virtual machines, and block unwanted traffic at no additional cost. We also offer DNS, right, which can help you easily add and manage domains for streamlined web hosting. We also offer DDoS protection, right, to safeguard your websites and applications to ensure uninterrupted performance. I want to zone in further because this session is specifically about how to manage traffic better with load balancers. Before we dive deep into the load balancers, I want to spend some time talking about some of the top challenges that many cloud network architects and network engineers face while helping manage their cloud resources. Right? Challenges include, like maybe one of the key challenges is there's uneven traffic distribution causing downtime or slow response time. Right? Like we've all seen it. One droplet, which is a virtual machine. We call virtual machines as droplets in DigitalOcean, right? So one virtual machine or a web server gets hammered while others are barely doing anything, right? That kind of imbalance leads to latency, drop requests, or worst case, even downtime, right? It's frustrating when you know your infrastructure has the capacity, but the traffic isn't just routing smartly. The second challenge could be you have unexpected bandwidth costs due to inefficient routing, right? Like bandwidth surprises aren't fun, especially when they show up on your invoice. If traffic is bouncing between regions or routing inefficiently across services, those charges stack up pretty quickly, right? And without good control or visibility, it's easy to burn the budget unintentionally, right? The third challenge could be related to complexity in choosing and configuring the right load balancer. There are options such as like a network load balancer versus a HTTP load balancers, regional versus global load balancers. I'm going to let Uday and Vasily share more details about those. But picking the right one shouldn't feel like a guessing game, right? The challenges is matching the load balancer to the app's architecture and your business's growth stage too. And once you pick the right load balancer, configuring that load balancer correctly is half the battle, right? We are going to give you guidance on how to do all of those. And the fourth challenge that I would like to share here is you could also have scaling challenges as your applications in your business or the user base for your business grows, right? Because scaling isn't just about spinning up more virtual resources or more compute, right? Your network strategy has to scale with it. Whether you're adding new regions, new containers, new virtual machines, or new services, right? Traffic management needs to evolve, or you'll start seeing cracks such as latency, inconsistent performance, or even security gaps. In order to provide more details about how to choose the right load balancers, how to configure them correctly, and how to manage your traffic using load balancers, I now invite Uday to share more details and help us make the best use of load balancers. Uday, take it away from here, please.
Thanks, Ananta. Good morning, everyone. So let me dive straight in. What is a load balancer? To start with that question. Load balancers earlier started off as a hardware product, but then it became a software, or now it became a managed service. So it can be a hardware or a software or a managed service that basically distributes the incoming traffic across your backend servers. So these backend servers, it can be within the same region or located in different regions. So every time when you face a situation where you have your application traffic being hit by thousands and thousands of users, this may be during peak times alone, or this may be a consistent amount of heavy traffic scenarios where you need to scale your workloads and you need to distribute the traffic across those workloads in order to sustain the incoming traffic. So load balancer is going to do that. It's going to solve that problem where it's going to distribute incoming traffic across your backend servers. Now, those servers can be droplets, that is VMs or Kubernetes clusters, or it can also be another load balancer if it is fronted by a global load balancer, as you see in the diagram. So one of the key things that load balancer does is, besides distribution, is the health checks. So it continuously monitors the health of your backend resources, be it droplets, Kubernetes clusters, and automatically detects which one is healthy and going to route the traffic to that particular server. So when this happens, your load balancer immediately distributes based upon the knowledge that it has, ensuring that your users never experience downtime. Next slide. So little bit, let's take a step back and understand why do we need them. The first thing, as we know, it's going to improve the availability of your application. That is, if a server gets hammered, as Ananta was mentioning, that's a single point of failure. And load balancer primarily helps your business avoid the single point of failure. Now, it, it, it not only avoids a single point of failure, it also eliminates the risk of sustainable traffic. That is, eliminates the risk of maintaining the large amount of load that you have to handle by distributing the traffic across different servers. Now, the second important piece is the performance enhancement. Now, as we just mentioned, the health check piece, where the load balancer is going to route to the server that's healthy based upon several aspects. In DigitalOcean, of course, this the way it going to load balance is not tweakable as of today, but it all happens at the back end. Like in that complexity has been abstracted, where it can be either round robin based algorithm, which basically chooses a way to route your requests, or it can also choose least connections, which means it chooses the server which has least number of connections so that it does not get hammered. And there are several other aspects of load balancing that the load balancer uses in order to distribute the traffic evenly. Now, when you think about this, the result of this is your application has reduced latency and significantly improved user experience. Now, the third important aspect is the scalability. You can add as many VMs, in this case, it's droplets or Kubernetes clusters within the pool of load balancers. That is, you create a load balancer and you can attach droplets. You can add as many droplets in, and you can remove as many droplets out of it, out of the pool, be it a maintenance or any other work, in a way that it does not impact the end user. So which means you can scale horizontally by adding more servers to the same load balancer pool. Now, this process is going to be seamless in DigitalOcean for you. The fourth important aspect is the security. Now, since the load balancer, let's take an example of HTTP load balancer, is going to have a TLS encryption, which is it's going to terminate the TLS connections. It acts as a buffer or like the guardrail between your users and your application servers. So you can prevent direct attacks on your backend infrastructure by fronting up a load balancer. And don't worry about whether the droplets go down or up, because the IPs which is fronted by the load balancer IPs, those are not going to change. In that case, you will have sustainable uptime for your applications. And finally, the maintenance operations. So when you need to update your application or your server, if you are performing any kind of server maintenance, you can temporarily remove them out of the load balancer pool, substitute with something that's working, and then add them back whenever you feel like. So this enables the rolling updates and zero downtime deployments, which is crucial for maintaining a highly available production environments. Next slide, Ananta. Now, a little bit on what are the types of load balancers that we offer, right? DigitalOcean offers two high-level types of load balancers. One is global and one is regional. And within the regional load balancer, you can see there are two subtypes, that is HTTP load balancer and a network load balancer. And both of these load balancers can work as an internal versus external. I'm going to explain a little bit more on each of these. On a high level, HTTP is a layer 7 load balancer, network is a layer 4 load balancer in the OSI layer. And internal, external basically signifies the exposure to public internet versus non-exposure to it. Internal does not have a public IP. Next slide. Now let's go a little bit more into the key aspects of HTTP load balancer. What is it, and what benefits can you anticipate from DigitalOcean's HTTP load balancer? Now, there are four key things to remember if you take a HTTP load balancer. So number one is it's going to be operating at the layer 7 in the OSI layer. As if you just a quick context, OSI layer, OSI model is basically the construct that which is the foundation for any communication in the internet. Now, with that, it has several layers. You can imagine that to be like an envelope which is having a letter inside with a lot of addresses in front of it, where it's just an analogy for that for us to understand, where you basically have a packet and you encapsulate a bunch of headers and traverse the internet. Now, with that said, this particular HTTP load balancer operates at the layer 7, which means it will understand the application level details. That is, it can understand the host information, URL information, header information, or path-based information of the application level, and it's going to route the traffic based upon that information. That's people call in the market as application load balancer. Now, the one thing that I want to highlight here is DigitalOcean's load balancer today supports host-based load balancing, and it is yet to support URL or path-based load balancing. The second important piece is SSL termination. Now, HTTP load balancer terminates the TLS traffic, so which means it can do the encryption and decryption, and which is basically offloaded from your backend servers. The backend servers doesn't need to worry about it because load balancer is going to take care of it. The third important piece is the session persistence. Imagine you're running a e-commerce app and you're adding you as a user. He's trying to add cart details or products that in their cart. Now, it's important for that user to, no matter how many times, how many browser sessions that he opens, how many HTTP requests comes in from that user, he should be able to see the same cart details, which means the session it should support the sustainability of the information, which means the session persistence helps out with it in HTTP load balancer. That ensures the user requests are routed to the same server again. The fourth important piece is the proxy protocol. Now, this is something essential for applications that needs to preserve the source IP. Like there are several important needs like security and compliance, which needs to understand or maybe filter the specific client IPs from abusing the application. So in order to enable that, the DigitalOcean load balancers, HTTP load balancers support proxy protocol support where the source IP is preserved. Now, if you think about this HTTP load balancer, specifically, it is useful for stateful web applications. Now, it can be e-commerce, web application APIs, and content delivery kind of applications that you deploy. HTTP load balancer performs well in that because it operates at the stateful web application level. And in the future, eventually, we will have the support for URL and path-based load balancing, which makes this HTTP load balancer into a full-fledged application load balancer. Next slide. Now, one key question you can think of is, okay, that's all good, but how do you understand how many load balancers we need? So this is specifically going to explain you how the value scales with price for you. So compared to other solutions in the market, we are approaching the pricing and the value in a simplified manner, where you can see each load balancer comes with default set of thresholds. That is, in this case, HTTP load balancer, the key entity that you need to look at is the simultaneous connections. At any point of time, one HTTP load balancer will support 10K connections, 10,000 connections, and it can support 10,000 requests per second, and it will support 250 SSL connections per second. Now, if you think about this, what would happen? How do you evaluate, like how many load balancers do we need? So you can take your baseline metric of number of simultaneous connections that your application sustains in a month. Let's say, for example, your application needs, at its peak, it needs 200,000 connections, which means you might need 20 HTTP load balancer node at this point. So this is how I would do the math of how many load balancers I would need, specifically for HTTP load balancer scenario. Next slide. Now, let's look into the network load balancer. Now that we saw HTTP load balancer, which operates at layer 7, network load balancer operates at layer 4. Now, what does it mean by layer 4 versus layer 7? Specifically, in order to simplify that, if you have, let's say you are given an envelope and you wanted to route it to you wanted to send it to your friend based upon the content in it. So there are two ways to do it. One, you can see the address of the envelope and then pass it on to the respective destination, or you can open it up and see whom it's addressed to, what's the context of it, and then route it to a specific uh, destination. Now that's the difference between a layer 7 and a layer 4 load balancer, where in a layer 4, load balancer doesn't care what is inside. It's just going to look into the TCP layer information and then routes it. In this case, as you see, there's no SSL termination. It's going to pass through the SSL, which means end-to-end encryption is already built in. It's not going to tweak, encrypt, or de-encrypt and things like that, which makes it less overhead. That is, the processing time is very less when it comes to a network load balancer compared to a HTTP or like application level load balancer. So that is a key benefit, which means network load balancer is going to give you a lower latency and a higher throughput. And you can pump in more simultaneous connections without worrying about the threshold. Whereas in case of a HTTP load balancer, you are limited by those simultaneous connections, right? As you saw a second ago. And this particular network load balancer is more suitable for stateful connection-oriented applications. What does it mean? Like if you think about any WebSocket-based chat applications, gaming, VoIP, streaming, and real-time bidding, and all these kind of connection-oriented applications benefit heavily by network load balancer because you're not bottlenecked by connections. You can pump in a large number of concurrent connections at the same time, and it is bottleneck only by the bandwidth. Next slide. Now that helps us to understand how the network load balancers scale. Now here, our DigitalOcean network load balancer, one network load balancer or size 1 network load balancer has the threshold of 50 Mbps ingress bandwidth. Now it supports, it's like a 50 Mbps pipe that you get with the 1 NLB. If you want more, you're going to increase the size of the NLB or create more NLBs as you need in the DCs that you need. Now, one thing you can think of is how do you estimate the number of network load balancers you need. It's again comes to understanding what's your peak P95 bandwidth or throughput usage at this point. So evaluate what's the P95 value of your customer's throughput or your application's throughput, and reverse engineer the number of network load balancers you need. In this case, 50 Mbps would give, at least in a month, it's 50 terabytes of data transfer possible if it's used consistently over the period of a month. Now, if your peak is 15, probably I would do more number of load balancers at this point, but that's the high level math I would do. Basically, take the ingress bandwidth and take your current baseline and evaluate how much would be the peak throughput in a month, and then reverse engineer the number of network load balancers you need. And one other specific is it only forwards TCP and UDP. It's not going to touch HTTP. It's basically for non-HTTP protocols. And there's no limit on simultaneous connections, no limit on requests per second, and SSL connections per second. There's no bottleneck on that. So what happens is you have less overhead, you get higher performance and lower latency. And compared to the market standard, we have seen scenarios of businesses who have saved 20 to 30% from when we compare to hyperscalers when they moved to DigitalOcean by opting network load balancers. Next slide, Anantha. Now the final piece is the global load balancer. Our global load balancer is a global HTTP load balancer, which means it's similar to regional HTTP. It's a layer 7 HTTP load balancer. It's going to route the users the closest, healthiest server region. And it has HA inbuilt, and it's going to automatically fail over based upon regional outages. So by default, it's going to be an active-active scenario. If you connect the droplets or the Kubernetes clusters to a global load balancer, you're going to have the traffic routed between both of them. You also have the ability to prioritize which DC you need the most traffic, and you can prioritize which DC has to be the first preference and which DC has to be the second and third. Now, the third important aspect is the caching. You can enable in a single click caching, which basically stores your images and web pages. Basically, what it does, it saves frequent additional requests to the origin server, so that it reduces the number of requests that is being served, because it's being served by the cache at the edge. And fourth one is backend flexibility. That is, you can connect a droplet or a Kubernetes cluster or a regional load balancer to a global load balancer. So most of the scenarios that I have observed in this is, in specifically the connecting a regional load balancer is on the Kubernetes side, where by default Kubernetes clusters happen to create ingress load balancer, which can be connected to a global load balancer for cross-cluster, cross-region traffic distribution. And final one is built-in DDoS. So the global load balancer comes with the default DDoS protection at the edge, so you don't have to worry about DDoS attacks for your servers that's behind XGLP. Next slide. Now, there are 3 dimensions. Again, for global load balancers, we have to look at and how it scales. There are 3 entities. One is the request per month, and then egress data transfer per month, and domains. So you have one GLB, and it comes with these 3 thresholds, like 25 million requests per month, 1 terabyte of egress data transfer, and 5 domains. Anything beyond that is for $15, and anything beyond, you will have an overage fee for the requests, as it says 100,000. For every 100,000 requests, it's 7 cents, and for every GB of overage data transfer, egress data transfer, it's going to be 0.02. So most of the time, you will save in these, because when you enable edge caching, you'll have less number of requests and data transfers. But just to give you an overview, this is how you can evaluate how you can leverage a global load balancer, how many GLBs you need for your business. Next slide. And last piece is the internal load balancer. So internal load balancer or DigitalOcean is only a regional construct. That is, it can be a regional HTTP load balancer or a regional network load balancer. Both of them can be internal, which means with a single click, you can make the load balancer get only a private IP. That is, without a public IP, you can deploy a load balancer as an internal load balancer. Now, why is this essential? There are a lot of services that you can you need to isolate it from public internet. It can be a Bluekey deployment, so it can be shared services which you want to isolate. It can be database related services that you have to isolate from your main front end or app tiers. Now, those kind of needs are easily sustained and helped by this particular internal load balancers, where you can keep these resources secure without exposure to internet or any other mishaps. And one thing to mention here is the internal load balancer is going to be routing the traffic to the resources within the VPC. It's similar to the regional load balancer. Next slide. Yeah, now let's look into a real demo from Vasily regarding how do we orchestrate all these load balancers for an effective business use case.
Demo, we're running a simulation of a gaming application that consists of 2 parts. The first part is the leaderboard, and the second part is the multiplayer game backend. Notice that the leaderboard is available to gamers over HTTP, while the backend uses UDP. Let's take a look at the leaderboard part first. We want the leaderboard to be available from multiple parts of the world. This will improve latency for players and also allow us to build a resilient application that can survive a disaster like flooding or fire. And to serve from multiple data centers, we'll need to use a global load balancer that you can see here. At the same time, we want to run our leaderboard on multiple servers within the region, both for redundancy and scalability, which means we'll also need regional load balancer that you can see here and here. So the leaderboard runs inside containers on our managed Kubernetes, and the gaming data is stored in managed Postgres in both locations. In this case, the Letterboard application runs in Amsterdam and New York, and we can add more regions if we need this later. And as I mentioned, the key part of this setup is the global load balancer that routes traffic to the region closest to the player in terms of latency. The Letterboard simulation is now live, and if I go to the gamingapp.digitalocean.solutions, I can see my request is being served by the Kubernetes cluster in Amsterdam because I'm located in Europe. What we do now is let's simulate an outage in Amsterdam. So I'll restrict access to the database here so no one can connect to it. This will cause the load balancer health checks to fail, and then the global load balancer should shift the traffic to New York. So let's see how it works. To demo the outage, I will go to DigitalOcean control panel. Let me refresh that. And as you can see, there are all the infrastructure components of the Letterboard, global load balancers, Kubernetes clusters here, and also the managed database. So I click the managed database, I go to settings, here and here in trusted sources, I will remove the Kubernetes cluster in Amsterdam just to simulate the outage. It usually takes some time for load balancer health checks to detect the failure, and health check timers are configurable, and in this case I've of course set them to be aggressive. So I've refreshed the page already, and we can see that the local database in Amsterdam has run aground. So the application detects that the database is offline. We can also see this in the diagram below, and if I refresh one more time, I should see that my request is now should now be served from New York. So global load balancer, this guy here, shifted the traffic to New York, and the regional load balancer now in New York distributes the traffic across Kubernetes pods to reach the Letterboard application. And notice in this case the regional load balancer is internal. Why is it internal? Because we don't want it to be external. This would allow players to bypass the global load balancer, which we do not want and which is a security risk. So far, we've talked about the global and regional load balancers, but what about network load balancers? A network load balancer is a low latency proxy with unmetered network connections. While a traditional regional load balancer bills you based on the number of network connections, a network load balancer provides raw bandwidth and bills you based on megabits per second of throughput. So where is this useful? For example, when running backend game servers like we see in the diagram here. On the left, we have players connecting to gaming pods running in Kubernetes over UDP via a network load balancer. So we want players to be routed to the same gaming pod or gaming container every time they connect. But a network load balancer does not support session persistence. It means that every new incoming UDP packet is sent to a random gaming pod. To solve this, we have a layer of proxy pods also running in Kubernetes. So this layer of proxy pods routes certain players to a specific gaming pods that belong to them. And how do we know which gaming pod to choose? We use a Valkey database to store the gaming session, which is Redis compatible. Now let me show you how it works. If I go to my terminal and if I send the UDP request with a port 9999 to our network load balancers, you can see that the network load balancer is replying, And here we see the container that we are being routed to, and container is different. So the network load balancer is sending traffic to different proxy pods, not just one. This brings this demo to a conclusion. We have explored different types of load balancers on DigitalOcean, and using a gaming service example, we saw where to use global load balancers, regional load balancers, both internal and external, and network load balancers. The last thing I want to show you is billing. In the billing section of the control panel, you can see the current breakdown of load balancer costs. So we can see global load balancer here, and regional load balancer, because they are part of Kubernetes, are located under the Kubernetes pods. So you can see we have a private load balancer here. Thank you so much for watching. I'm part of the solutions team at DigitalOcean. If you have more questions about load balancers or any other DigitalOcean service, feel free to reach out. We'll be more than happy to help.
Thank you, Vasily. That was a cool demo. I really enjoyed how the live demo was immediately able to pick up and route to the New York resources. Very cool demo. And also the building sections were very helpful for me as well. Thank you for showing that. Really cool demo. Vasily and Uday, did you want to just walk us through information about how customers who got tons of information about various load balancers and demos choose the right load balancer for their needs?
Yeah, I can touch a little bit. So what I have here is basically a high-level initial way to think about how to choose a load balancer. This is not the holistic scenario, because all I have here is the type of apps that you are trying to build and how to think about creating a load balancer. Now, first question that I would ask myself if I am incorporating a load balancer is, okay, am I deploying something regional and I need to scale the workloads at the regional level, which means I'm constrained with the resources within a data center. Now, if that's my scenario, basically I need a regional load balancer. And first question is whether it's a regional or a global use case for me. Now, if it's regional, the second question I would ask is whether I am going to deploy a stateful web application, or is it a stateless application, or is it a stateful connection-oriented application. So an example would be by deploying something like a weather app where a user can just go in and check something, which is basically stateless. There's no need for users' sessions to be maintained for anybody who's checking anything. But in the case of stateful web apps, imagine like an e-commerce application where there needs to be some form of user information to be stored, or you need a gaming or an analytics bidding kind of application, that be stateful connection oriented application. So if I'm building a stateful web app, then of course I would need a HTTP load balancer. If it's a stateful connection oriented app, then I would be more benefited by a network load balancer because I need lower latency and higher throughput. And if we think about the other side, if I am looking for a global load balancer, then again, if it is a stateful web app, then I would need to choose a global load balancer where I can connect my domain and route to the domain across different regions, servers that's located in different DCs. Now, one other aspect is among all these is if I am considering within regions, do I want to secure my applications without any public internet exposure? And I have a couple of examples that might follow these slides, but quickly, if it needs to be secured from any other applications or any other services or exposed to public internet, then it would be beneficial for me if I choose an internal load balancer. Whether it's a HTTP or a network we can evaluate based upon the type of app that I'm building or type of service that I'm serving. So that's how I would like to think about, at least to start with, how do I come up with which load balancer to use? And there are other kind of applications like event-driven apps and batch processing apps and things like that. But to start with, these would be my high-level thinking on how to approach which load balancer to use.
That's helpful, Uday. Thank you. Can you also walk us, like we have a couple of more minutes, can you also quickly walk us through some of these key business use cases? Then we'll take like one or two questions and then wrap up this session.
Yeah, I want to point out, like, let's take this first use case, like the more familiar use case, a global social network platform like Facebook, right? Now, if somebody wants to start up something like a global network platform, if you can see in this architecture, user accesses the platform through a domain like a socialapp.com, managed by the GLB, fronted by the GLB to start with, and that'd be the first point of contact to make the critical decision to route the users to the nearest data center. It can be New York, east, west, whichever the region you want. It's going to route to the respective data centers based upon the health of the servers in each region. Now, once that reaches that particular region, you can see now the application tier is fronted by the regional load balancers. So the standard web request for the main application goes through the regional HTTP load balancer, which handles the SSL termination and distributes the request to the Kubernetes clusters. So the Kubernetes clusters, as you can see, runs the web front end and the newsfeed logic. Now, the key aspect here I want to highlight is in this architecture is how it handles the real-time communication. Of course, there will be a chat pane that you wanted to chat with other users. Now, when a user opens a chat functionality, you can imagine that that would open up through another subdomain like chat.socialapp.com, and that could create a WebSocket connection established through a separate network load balancer here, because it's a stateful connection-oriented application. Then that needs to be fronted by a network load balancer. Now, this is crucial because WebSockets require persistent connections, and network load balancers is optimized for this type of traffic that would give lower latency and higher throughput. Now, what is this architecture demonstrates? Number one is global distribution to minimize latency for the users worldwide. Number two, workload separation to optimize each type of traffic with appropriate load balancer. And number three is the independent regional scaling ability to handle various traffic patterns across different geographical areas. So this is one like known use case that you can leverage DigitalOcean to deploy using the existing different types of load balancers. And there's another use case which I would like to share. Next slide, Ananta. Now, this is a example of a multi-tenant SaaS platform with shared services. Now, if you can see here, just imagine like a work collaboration tool. Now, in this, each customer has their own workspace kind of SaaS app where they have their own dedicated, that's been fronted by a dedicated HTTP load balancer and application tier running in an isolated VPC. Now, the isolation is crucial for security and compliance reasons, and each customer's users access their specific application through dedicated load balancer. Now, these route traffic to the application servers running either in Kubernetes or Droplets depending upon their requirements. The key aspect of this architecture is how it handles the backend services. Instead of duplicating the common services like authentication, billing, analytics, notification, all these stuffs, and logging, for each of these customers separately, they can be centralized in a shared service VPC. Now, the VPC can be connected to the app tier using the VPC peering. Now, as internal load balancer, an internal load balancer within this VPC will distribute the traffic to the shared services, which connects to the database that maintains tenant isolation at the data level. Now, as you can see, we have leveraged both VPC peering, and we have leveraged internal load balancer to isolate the connectivity from the public internet and enable the internal traffic distribution, as well as we leverage the regional load balancer for the public facing traffic as well. So this architecture delivers three major benefits. One is that you have strong customer isolation through separate VPCs and load balancers, and you have cost optimization by using a shared backend services across all customers. And you can simplify management like maintenance, since updates to these shared services immediately benefit all customers. Now, for SaaS businesses like this approach provides excellent balance of security and cost optimization, and increases the operational efficiency for the business. With that, I would like to move on to the next key aspects of it. Now, of course, every thing comes with a limitation, right? Now, today, what is our limitation? What are the limitations that we have in DigitalOcean load balancers? Number one, you cannot connect a one regional load balancer to another regional balancer. Of course, it has to be connected to a Droplet or Kubernetes cluster. The IPv6 support is there for load balancer, but it cannot assign v6 address post creation. That is, while creating a load balancer, you can assign IPv6, and you cannot assign an IPv6 address post creation of a load balancer. And within that, reserved IPv6 support is not there yet. And another key aspect is the GLB. GLB does not have web application firewall support yet, which is something that we are planning to work on. And finally, HTTP load balancer is not a full-fledged application load balancer yet on us, on our platform. So it does not do a URL or path-based routing or any header injection today. Now, it's still a host-based load balancer, which also operates in TCP mode, but it's going to have higher latency because of the double proxies that it exhibits in the traffic flow. But this is something that we are planning to alleviate by making it a full-fledged application load balancer in the future. And yeah, those are the key things that we have to keep in mind in DigitalOcean load balancers, and open for any questions.
Thank you, Uday and Vasily, for helping us answer tons of questions on the chat as well. I see that there were tons of questions on the chat, and Vasily, thank you so much for answering most of them. I'm going to request our audience to ask any additional questions, or Vasily and Uday to just go to the chat and see that there aren't any follow-up questions from them. But as we close, what I want to share is we want, again, thank you for joining us today, right? Like, as we wrap up today, we have 3 specific offers to support your cloud journey, and choose what fits for your needs, right? For example, if you're a prospective customer, right? If you're a business looking for a simple, scalable, cost-effective cloud platform, right? You may want to try DigitalOcean, right? To help you with that, you can scan the QR code that you see on the left side of the screen, right? To receive a $200 in usage credit, and you can try and explore DigitalOcean and see what it can do for you, right? If you're an existing DigitalOcean customer and you're looking to improve traffic management, right? If you want to set up these load balancers that you've heard during this session today, right? You can scan the QR code that you see in the middle of the screen, and you may qualify for a $100 usage credit when you set up a load balancer by end of August, right? Make sure to register your contact info so we can email you all the offer details as well. So you can either scan the QR code, or you could use the URL that you see to register, so that we could email you all the info about this video link as well as the offers pertinent for you, right? And then if you are someone who needs a bit more expert guidance, right, specific for your business to optimize your cloud, right, like whether you are a prospective customer or an existing customer, you can scan the QR code on the right side for a free consultation with one of our cloud specialists, right? You can get tailored advice to strengthen your cloud architecture, reduce costs, scale efficiently, and improve backup and disaster recovery. A variety of topics, right? How to set up multi-cloud and things like that, right? That can help you boost your performance, reliability, and save some costs too, right? So request you to scan and register to get an email with all the video links and pertinent offers as well, right? Uday and Vasily, any closing thoughts before we wrap today's session? Is there any point from the chat discussions that you feel was repetitive, or do you want to emphasize again before we close? Vasily, did you see anything that you want to just add a bit more color to it?
I'm good, thank you guys. Great questions in the chat, and I hope I answered them well. So Uday, if there's something wrong, just let me know.
Yeah, those were great questions. Yeah, thanks Vasily for keeping the chat going, and thanks for answering all those quality questions, and thanks for everyone for chiming in with questions. So glad to see those answers and conversations in there.
Thank you, everyone. Again, we'll team up. We request you to come sail with us, right, on the journey to make a simpler, more affordable cloud work for your business, right? And at DigitalOcean, we are committed to empowering your business growth with the right tools and support you need to thrive, right? Let's team up together to navigate your cloud journey and make sure your networking is seamlessly managed for a smooth and a successful path towards growth. Thank you again. Take care. Bye.
Thank you all.